Hello out there. Welcome to a C programming video. Today we're going to make the classic game Frogger. Before we start programming, there's a few things to consider. First, the graphics. We will be using images on a sprite sheet. Everything on this most professional image aligns to a 32-pixel boundary and can be 32 or 64 pixels long. The small numbers being an exception, those align to a 16-pixel matrix. When I display a grid over the image, you can get an idea of how we're going to be able to use rectangles to describe the positions of the images we want. For instance, if I want to display this car, I have to move 0, 1, 2, 3, 4, 32 pixel boxes over, and 0, 1 pixel boxes down, and I have a source X and Y, and a width of 64 and a height of 32. Also, Frogger is a game with iconic sounds, so let's make some sounds of our own. Pick up a guitar and... Ah, yes, perfect. Those effects will never get old or annoying. Way to go. Now let's think about the game board and how we're going to design it. We're going to want a top row for displaying information such as score and level. We need a row for the lily pads, 5 lanes of water followed by a midpoint row, 5 lanes of traffic followed by a safe row and another information display row. This setup mimics the old school game pretty well. Now we have to think about the mechanics for a second. What and how we want things to happen during play. Instead of having the same cars per lane, although classic as shown above, it'd be more interesting to have many different cars in every lane and make them sporadically spawn. The logs will have crocodiles hidden among them. Watch out for those jaws. The helpful turtles may not be helpful yet, as some will sink, luring you to your demise. We will use a scorpion as the menace for the mid. Lastly, a bonus frog that randomly spawns to award you extra points when you land home. Now that we have our goals in mind, let's imagine how we need to proceed. The logs, crocodiles, cars, turtles, frogs, lily pads all need collision detection and a structure to define them. So let's start there. First, the object structure has a floating point value for X for smooth scrolling for objects, and while the frog is riding those objects, our Y values are going to be in 32 pixels increments. To stay in the lanes we created earlier, the width is for collision purposes. Not all the objects share data points, so we segmented it into a union so that we won't make our structure larger than it has to be, but more multi-purpose. Alive? Are we alive? State, what state is the object in? Is floating or sunk? Is it an open or closed mouth? Is it tethered to our hero frog? What model is it? This is applicable to the cars for indexing the image from the sprite sheet. We have another data point split, the type and direction. Cars and frogs have direction, while the logs and turtles have types to tell if they're sinkers or even crocodiles. Here is our object collision detection. Check the first object's X offset value and make sure it's between the X value and size of the second object, and that it's the same Y value. Next, think about our game struct, as we're going to be passing around many variables, and it's cleaner than making them all global. This is our game struct, and it includes things like our objects, start time, lives, score, renderer, and more. We will be setting this game to run at 60 FPS. Before we get too far, let's make sure we have a way to load and free our resources. Since we're using pings, we're going to use SDL image on top of vanilla SDL. We're using the vanilla SDL for sound since we don't need to take in consideration music and won't be using mixer. We need a way to initialize our objects and reset them. So here we have all the reset functions. The game function resets all of them. But since we sometimes have reason to reset out of the main reset, we're going to keep them separated. The reset for the frog, scorpion, and lily pads is always set to the same locations. However, all resets except the frog set a velocity. Resets such as the bonus frog and crocodile over the lily pads just hide the object and make it inactive unless on level 4 when the crocodile can spawn. Resets such as the log, turtle and car reset are more involved. The turtle reset will select the type and set the initial state to floating. Like the turtle reset, the log reset will set initial type, including crocodiles after level 2. The car reset sets model. A model of 0 makes the gaps in the traffic. The car objects are unique as there are 30 of them always going to keep spacing, but only some of the models are active and the speed is also determinate on the level. On to drawing. First we need to draw our game board. Here is our function that handles it. Here we draw the individual strips that make up the lanes, the lines in the street, as well as the score counter and level counter. The amount of lives displayed is also handled within this function. Here are the other individual draw calls. Here is the function that calls all the draw calls. Updating our positions of the objects is the next task. It handles the frog, the logs, well, all of it as well as collision, so we know if we hit something and to behave accordingly. The updates also handles the wraparound behavior. We do this instead of just using a wraparound counter because of the need to change the object type on respawn. Here is the car update. It uses a random algorithm to decide if a car should be present or a space should be used. It decides the model of car if there is one present. It also checks if there is a collision with an active car. If so, it returns true and you lose a life. The log and turtle updates are similar in that they both pick a type when they respawn. If the hazard type is picked, the sinking turtles or the alligator, they then check against a timer monitoring the seconds played so that every 4th second for 1 second the hazard is active. Again, this, along with the scorpion and crocodile head that appears in the lily pads, all will return true if you collide, causing you harm. The log update is also responsible for generating a bonus frog when the conditions are right. The bonus frog update simply rides the log unless you change its type by colliding with it. It then will mirror your movements until you die, and it's reset or you land on a lily pad. The water objects all return true if you collide with them as well, but here it's necessary if you want to stay above water, as past a certain y variable, the expectation is you are colliding or you're dead. The lily pad update is unique in that it will look for both you and your partner to allocate scoring as expected and to reset both frogs. Inside of the main function, we set up our window, create the renderer, set initial conditions, and in our loop we run our various updates and make sure we're still alive and going, otherwise we go back to the title screen. This video is getting a little long to explain everything in detail, but it's pretty straightforward, and a link to the code is in the comment section. To finish out the video, here is some development footage of parts being tested as I wrote them. So enjoy, and until next time, thanks for watching.